Hello, my name is Muksit, and this is my individual research representation for CS 7080NM, Cloud Computing and IoT of Things. Uh, as part of the MSc Artificial Intelligence program at London Metropolitan University. My report and presentation focus on IoT-based warning systems and specifically on the legal, social, ethical, and professional issues that arise when these systems are built on cloud infrastructure. Moving to the second slide, uh, let me briefly walk you through what I'll be covering today. I'll start with an introduction to the problem, then outline my research objectives and review the key papers I drew on, explain my methodology, and then the most time on the LSEP issues, which are heart of this report. I'll close with a discussion of findings, conclusions, and suggestions for future research. Moving to this third slide. Um, flooding is, if I give an introduction, flooding is one of the most destructive and frequently occurring natural disasters in Sri Lanka and worldwide. Traditional warning systems, which rely on manual observation and centralized meteorological reporting, are often too slow, too limited on coverage to protect communities effectively, particularly in developing regions. The emergence of the Internet of Things and cloud computing has changed what is possible. Sensor networks can now be deployed across rivers, drainage systems, coastal lines, feeding real-time water levels data to cloud platforms like AWS or Microsoft Azure, where it can be processed and used to trigger timely alerts. However, and this is central argument of my report, while the technical side of these is well developed, the legal, social, ethical, and professional dimension have received far less attention in the research literature. That gap is what this report addresses. So moving to the fourth slide. Coming to the research objectives, my research has four main objectives. First, to summarize the current state of IoT and cloud-based flood warnings research using Siddiq Ahmed and Hussein's 2023 as my primary reference. Second, to critically contextualize that paper's findings against a broader body of literature, identifying what has progressed and what remains unresolved. Third, to examine the LSEP issues that arise in the domain in depth. And fourth, to identify research gaps and propose directions for the future work. So coming to the literature review, uh, my primary paper is Siddiq Ahmed and Hussein's 2023 work, Flood Monitoring and Early Warning Systems, an IoT-based perspective. This is my comprehensive survey of IoT hardware and cloud architectures used in flight detection. The authors evaluate sensor types, communication protocols, and cloud backends, and make a strong case for cloud scalability as essential during actual flood events. However, the paper is predominantly technical. LSCP considerations are essentially absent. So to contextualize this, I drew on three supporting papers. Agbahaji and colleagues writing in 2023 conducted a systematic review of cloud-based early warning systems and identified data sovereignty and regulatory compliance as persistent challenge. And Kaus and colleagues in 2021 proposed an energy-efficient IoT cloud framework using machine learning to process data at the edge before it reaches to the cloud infrastructure. And Al Rawas and colleagues in their 2024 review were among the few to flag that black box nature of machine learning models, predictions, and as an emerging ethical concern. Together, these papers confirm a clear pattern here. The field is technically mature but socially and ethically undeveloped. So moving to the research methodology, I will say my methodology was a systematic literature review. I search IE Explore, Google Scholar, MDPI, Springer, and Science Direct using keyword combinations such as IoT flood warning, cloud computing disaster management, and LSEP IoT. I prioritized papers published between 2015 and 2025 with a preference for high citation counts and open access publications, where technical papers lacked LACP discussion. I supplemented my analysis with frameworks such as GDPR, the IEE Code of Ethics, and the UN SEDI framework for disaster risk reduction. Moving to the seventh slide, uh, let me turn to the LACP issues here. Starting with the legal and social dimensions. On the legal side, the most pressing issue is data governance. Flood warning systems that integrate with mobile alerts applications or track user locations are subject to GDPR in the European context. The This introduces obligations around consent, data minimization, and the right to an erasure that rarely are acknowledged in the engineering literature. A further complication is data sovereignty when sensor is processed on servers located abroad. As is common with major cloud providers, questions arise about which legal frameworks that applies. Uh, Perhaps most urgently, there's a liability vacuum. When a cloud connected warning system fails to alert a community in time and lives are lost. It is currently unclear whether legal responsibility lies with the hardware manufacturer, the cloud provider, and the system integrator, or the responsible government authority. This is an unresolved issue that the research literature, including civics papers, doesn't address. On the social side, the most significant concern is equity. Systems that deliver alerts exclusively through smartphone apps may exclude elderly people, low-income households, and those in areas with mobile coverage, precisely the groups most at risk. There is also a question of community trust. If residents have experienced repeated false alarms, they may not respond appropriately when a genuine warning is issued. These behavioral and social dimensions are almost entirely absent from the technical literature. Moving to the ninth slide, the moving to the ethical and professional dimensions. Ethically, one of the most important issue is sensor placement bias. In resource constrained deployments, sensors tend to be concentrated in wealthier or more densely populated urban areas. This creates unequal protection. Rural and poorer communities receive less coverage, which raises a clear question of environmental justice and fairness. There is also issue of algorithmic transparency. Several of papers I reviewed, including Al-Rawas and Cow's paper, incorporate machine learning for flood uh, prediction. When an AI model triggers a mass evacuation alert, the basis for the decision may not be interpretable even by the authorities acting on it. Decision affecting human safety need to be explainable. Requirement that current systems do not meet. Third ethical concern is commercialization. Deploying critical public safety infrastructure on commercially operated cloud platforms means that service continuously is governed by commercial contracts, not public interest obligation. On the professional side, the IEE Code of Ethics requires engineers to hold public safety paramount. In the context of flood warning system, this means systems must be rigorously tested, properly redundant, and actively maintained. Sensor network degrade, cloud APIs challenge, and machine learning models and needs retraining as climate pattern shifts. No formal professional standards currently exist for IoT-based safety critical public infrastructure a significant gap in Sri Lanka. So, coming to the ninth slide, my discussion brings together four main findings. First, there is a clear mismatch between technical maturity and LSEP maturity. The engineering solutions are impressive, but the non-technical dimensions have been systematically neglected. Second, the liability vacuum I mentioned is not just a theoretical concern. In a real-world failure scenario, the absence of clear legal accountability could have serious consequences for both affected communities and the organizations involved. Third, social equity needs to be embedded at the design stage of these systems, not added as an afterthought. So this requires involving community representatives in the design process from the outset. Fourth point is the field is too narrowly dominated by engineers. Genuine progress on LECP issues require interdisciplinary collaboration, bringing in legal scholars, ethicists, sociologists, and policymakers. So, coming to the conclusion and future research, in conclusion, IoT and cloud computing offer genuine, powerful capabilities for flood warning. The technical case is well established, and but the LSEP dimension legal accountability, social equality, ethical transparency, and professional responsibility are critically underdeveloped in the literature. Future research should develop interdisciplinary design frameworks, create formal liability standards for IoT public safety systems, design alert delivery that reaches offline and vulnerable populations, and establish explainability requirements for ML models used in disaster prediction. As climate change make flooding more frequent and severe, getting this system right is not optional, it is a matter of life and death. So, coming to the references, here are the key references used in this report and presentation, all formatted in Harvard style. Full details are provided in the written submission. So finally, thank you very much for watching. The full recorded video of this presentation is available at the YouTube. I hope this report and presentation have offered a useful critical perspective. I misspoke. Sorry. I hope this report and presentation have offered a useful critical perspective on on an important and growing areas of research. Yes. Thank you.